In this video, we are going to see a very good application of determinants. It is the Cramers rule to solve systems of linear equations. The Cramers rule is named after Gabriel Cramer, and it is a formula that uses determinants to solve a system of n linear equations which will have unique solutions. The general rule for the Cramer's rule is, suppose if we are considering three linear equations using three variables, x1, x2, x3, where the coefficients of these unknown variables x1, x2, x3 are a11, a12, a13, a21, a22, a23, a31, a32, a33. And on the right hand side, what we have are pure constants b1, b2, and b3. Let us assume that we are trying to solve this system of linear equations. When we are trying to solve the system of linear equation in using Cramer's rule, first we have to create a matrix A, which is called the coefficient matrix. That is, we have to take the coefficients of x, y, z. In this case, we have a 3 by 3 matrix because we had three equations. So when taking all the coefficients of x, y, and z, we can create a matrix using the coefficients. So that is a coefficient matrix. And let us create another matrix A1, where A1 is obtained by replacing the first column of A by just the constants in that system. The constant in that system were B1, B2, B3. So you are replacing the first column here by the constants B1, B2, B3. The remaining two columns are the same. The same way, A2 is a matrix. By replacing the second column of the matrix A, the coefficient matrix, by the constant. So your A2 will be the same as A, except that the second column is replaced by the constant. And A3 is a matrix replacing the third column by the constants in that system. So your A3 will be, the first two columns will be the same as A, and the last column A will be replaced by the constant B1, B2, and B3. So if we have the system of equations, then the value for x3 will be a3 by a, the determinant of that matrix. So we had the matrices A, A1, A2, A3. We can find the determinant of the matrices. You can find the determinant using your graphing calculator itself. So A3 will be on top and the coefficient matrix A will be in the denominator. That is your x1. The same way you can find the value for x1 and x2. So in general, if I have n system of linear equations with n variables, then we can find the coefficient matrix, and this coefficient matrix must not be equal to 0. That is, the system should be consistent. So x1 will be the determinant of a1 by determinant of a, x2 will be determinant of a2 by determinant of a. In general, xn will be determinant of an divided by determinant of a. Let's do this problem for example. x1, x2, x3, x1 plus x2 plus x3 is 20, x1 minus x2 plus x3 equal to 4. 2x1 plus x2 minus x3 is 16. So we have three equations with three unknowns. We are trying to solve for x1, x2, and x3. So the determinant matrix will be 1, 1, 1, 1, negative 1, 1, 2, 1, negative 1. And the constant here, b1, b2, b3 are 24 and 16. So using the previous theorem, we know that x1 will be determinant of A1 by determinant A, so which is 40 by 6 or 20 on 3. X2 will be determinant of A2 by determinant of A, which is 40 by 6 again. And X3 is also determinant of A3 by determinant of A, which also gives us the same result, 40 by 6. So the values of X1, X2, X3 can also be obtained using this Cramer's rule, where the Cramer's rule involves only the determinants of the matrices. When we are finding the determinants, we find the determinant of the coefficient matrix, and then we find the determinant of the matrix replaced by the constants. If it is x1, replace the coefficient of x by the constant. If it is a2 for x2, you have to find a2. a2 will be replaced by the second column will be replaced by the constant, and for A3 the third column will be replaced by the constant. So in this video we saw a very good application of determinants, which is called the Cramer's rule. We used Cramer's rule to solve systems of linear equations, whether the system is in terms of 2 variables, 3 variables, 4 variables, or in general if it is n variable. It is easy to solve for x1, x2, x3, xn using Cramer's rule. Hope this video was helpful in understanding how to find the solution for the systems of linear equation using the determinants. And this method is called the Cramer's rule. Thank you for listening. Thank you for watching.